Okay, so I'm Laura Fay. Again, I work in winter operations and I do everything from lab work, testing deicer performance and working with deicer companies to reformulate and test new ideas, to using kind of all the data that comes from the field environment to help make better decisions. And I do work with state DOTs at the national level and then also with local folks. So part of my passion is conveying information that can be usable to help change practices. And that's really what this talk is about. So how can we use the information we have to put less salt out there, to save money, to be more sustainable? It is possible, and it is possible with the information that we have today. And I just wanted to point out, I took these two photos on this opening slide. The right-hand photo is a train platform in Baltimore. And yes, that is all deicer, all those white dots. And the left-hand photo was taken last night at my younger child's junior high on the way into basketball practice. So I don't think it matters if you are salting your driveway, salting a sidewalk, a parking lot, or a road. We all have room for improvement. And this is really what this talk is about. So hopefully there will be some positive energy that kind of comes out of this for implementing change. So what we're asking or encouraging folks to do is use what you already have. We're not going to ask you to make a big investment, to make a big change. Instead, reducing salt use where you can be fiscally responsible and sustainable, and where those intersect in balance is what we're targeting. So maybe that's modification of something that you're already doing, starting with the easy stuff. And that's really what I'm going to go over in the talk today. Because a single small change in your daily practice and your organization, if you spread that over either your whole organization, a whole winter season, that can actually lead to really big change. And that's what we're asking for here. Larger investments in technology, staffing, all that can come later. Let's do the easy, low-hanging fruit investments in change now. So what's an example? I always start talks talking about calibration. And when we talk about calibration, we're talking about figuring out how much material, so that's liquid or solid de-icing product, that's coming out of the back of your vehicle. I guess in the example of the pictures on the first slide, it would be how much is coming out of either the hand push spreader or the bucket that you scoop into and you throw out on the train platform. But calibration is very important. It's important to know when you're doing it and how often it should be done, and for what products. So really quickly, it is always recommended that if you are putting de-icing product out there, you calibrate at least before the season starts. And when I talk about calibration, I'm essentially talking about you measure how much material comes out when your settings are at your normal dial point or value for your vehicle. It might be the height of the back of the bed. It might be a dial inside your truck. They're all different. And so what I did here was I went and I just did a quick Google search and I took the top 3 hits for how to calibrate your spreader that were on the internet. Some of these are made by deicer companies, some are made by spreader companies, and some are made just for general consumption. I'm not condoning any single product, but they show that for different products and different equipment, you do need to calibrate slightly differently. So if watching these videos is too overwhelming for you, or it doesn't speak to the equipment you have, please reach out to me. I work with folks all the time that are retired DOT staff, and they travel around the country and they will do on-site calibration trainings with your specific equipment to help implement this change in your organization. So why would we want you to do this? Well, you want to know how much product is coming out of the back of your vehicle. And I'm going to give an example of that. You can see here on the slide. So there was a gentleman, he came to a conference similar to this. and he listened to a talk about calibration. He went back to his shop and he said, I just want to see what we're even putting out on the road. I don't even know if we know that. So he asked the drivers to get in their vehicles. In this case, they turned a knob in the vehicle. He said, turn the knob to where you normally set the spreader. We're just going to measure that application rate, what's coming out. And just from that exercise alone, they realized that all of their fleet, they were putting out 500 to 1,200 pounds of material per lane per mile. And so pounds per lane mile is a common unit that we use when we talk about application rates. What's interesting, though, is that when you look at a lot of the guidance on application rates, the max amount you're going to see is maybe 300 pounds per lane mile for use. So this gentleman said to his drivers, he said, okay, we're going to calibrate our vehicles because they're all going to read slightly different. And then we're going to target a 250 pound per mile application rate. I'd like you to just try it. Just go out there for this storm, try it, see how it works. And lo and behold, it worked well. They achieved the same level of service. And just from that one change in one season, they were able to save $75,000 just from this calibration exercise. So imagine if one shop, one parking lot treatment company expanded out to the next shop, the whole agency, the whole organization. That's huge cost savings. That's huge material savings. Overall, it's just a win-win for everybody. And this is just one example of how to find little areas for improvement. So what's another example? Pre-wetting. So pre-wetting is where you, for example, have a rock salt that you're going to put out on the road, and you actually add liquid to that. So sometimes if you have a really fancy piece of equipment, the spreader where that solid material comes out actually sprays liquid as it comes out of the back of the truck. But you may not have the ability to do that. You may not have that advanced technology. That's okay. In your shed, you could spray down your solid pile. As you load your solid material into the back of the truck, you could spray it down. And you can pre-wet with just about any liquid. If you don't have salt brine on hand or mag chloride or an ag, like a beet juice or something like that, that's okay. You could even use water. The premise is by adding a little liquid to that solid, you're going to keep it workable. It's going to land where you want it to on the road, and it's actually going to stay there. And there's been quite a few studies that have studied the concept of pre-wetting. And basically what they found was that if you pre-wet your solid material, you're going to save 25% as it drops out of the truck. It's going to stay on the road instead of being cast off the road into the environment. So that 25% savings right there is reason alone to consider pre-wetting. But they also did a little more detailed research. And this was done by a state DOT, and this was done on site for them. And they had their actual plow drivers help with the study. So it was really cool. Essentially what they found was for them, pre-wetting works. It saves material, it keeps it in the road where you want it. And the slower you drive, the more material is going to stay where you want it to. So ideally you would drive 25 miles per hour. I know that's very slow, especially at highway speeds, but if you can slow that vehicle down, you're going to encourage more product to be where you want it to be. But as you incrementally increase the speed, more and more material is cast off the road. And I put the link here so you can go to this report. So this study has actually been duplicated twice by them. They did it initially, really promising results, and then years later, they wanted to confirm that this was still the case. And they did. It's pretty amazing work. So what does this mean in the long run? Okay, pre-wetting works. It reduces bounce and scatter of product. But what does that mean financially? What does that mean for us as an agency? Well, if you, for example, and I just took these numbers, these are big numbers, but they're real numbers. So at the time in 2012, the state of Michigan bought salt at $60 a ton. Their total salt budget was $3.5 million. If they drove 35 miles an hour and did not pre-wet the salt, so you can look down here to this kind of orange yellow 35 miles an hour untreated, so dry salt, they're losing the equivalent of $1.8 million worth of product just from that practice alone. If they slowed down to 25 miles per hour, if they pre-wet, their amount of potential loss goes down to about $350,000 worth of product. So ultimately, slow down, pre-wet, it all works. And again, it can be done in a really simple way. It does not have to be a fancy piece of equipment doing this. So what are some other practices that we can use that are going to help us? Well, using liquids in winter operations is something that we really encourage. And we call that anti-icing. And using liquids is typically done before a storm event. So if a forecast says temperatures are dropping and we're going to get some precipitation, you would then flag your crews to go out, and you could pre-treat the sidewalk, you could pre-treat the parking lot, you could pre-treat the road. These pictures all just happen to show road treatment, but you can do this anywhere. You could do this on your driveway. You go out, you put the liquid down, and that liquid serves to help prevent snow and ice from sticking to that pavement layer, so that when you do come in, it's easy to clean up. So what are we looking at here? Well, there's really good guidance on how to anti-ice. So what you can do is this is just one example of a report, but they provide detailed information on the temperature regime you're in, the conditions. So is it snowing? Is it black ice? Is it light snow? Is it heavy snow? The type of product, do you have salt brine available? Do you have mag chloride available? There are other products. They also talk about this in this report. What are typical application rates that you're going to want to start at? So for example, for salt brine use, when you look at this entire chart, the range that they recommend is anywhere from 44 gallons to 165 gallons applied in a single lane of road over 1 mile. And when you think about that, that's actually not a lot of material. If you go back and you think about when we were talking about de-icing and pre-wetting, we're talking about 250 pounds of salt over that lane mile. So just by using anti-icing alone, you're significantly reducing the amount of salt or de-icer that you're putting into the environment. So anti-icing is a best practice. It's been shown to be cost effective in multiple studies, and there's a ton of guidance on how to do it. I think the biggest hurdle here is if you don't have liquid application equipment, how are you as an agency going to get into that? Well, there's a ton of guidance on that. And I would actually suggest you reach out to myself or Allison, or look up the American Public Works Association. They do a liquids training series, and that can be very beneficial for how to start using liquids in your business or operation. So what are we talking about in terms of savings? So this is an actual example from a person that treats parking lots, and he provided this data to us. So what we're looking at are 2 retail store parking lots. We had a 1.5 inch snow event. We had 15 degrees, so pretty cold, but salt brine will work. And these were only 2 miles apart. So the footprint of the parking lots was very similar, about 250,000 square feet. Parking lot 1, they went in and they pre-treated. So they anti-iced with liquid. They put 28 gallons down on the entire parking lot. The other parking lot at site 2, they did not use any liquids. After the storm, they went in to clean up. They needed an additional 500 pounds of rock salt to treat other issues that they had. And their cost for that was just under $80. Parking lot 2, because they did not use any liquid ahead of time, they had to use 1.5 tons of rock salt, so 3,000 pounds to treat the parking lot to get it to the same place as the other one at a higher cost of about $125. So just looking at this alone, the amount of effort and material and costs for store one were less, just from using 28 gallons of liquid, which is pretty amazing. But the other feedback from Eric was that when they went and they pre-treated, it allowed for safer conditions when they did come in to plow up the material. It was easier for them to clean it up, took less time. And ultimately, overall for his organization, it was 37% cheaper to start anti-icing ahead of the storm than to use their former normal practice of just putting rock salt down. Imagine if you could take this from one parking lot to 2 to 5 to 10 to all the Walmarts across the country. That would be a huge reduction in salt use, salt in the environment, and a huge cost savings. So there's potential from very small changes to lead to big changes overall. Now we're talking about salts and reducing salt use. And so I have to talk about the fact that there are products out there, there are de-icing products that are not salt. They are made of other things. Common ones are acetates, formates, and glycols. And I have a picture of an airplane being de-iced because those top 3 products are typically used at airports because they are non-corrosive. So you do not want to start putting rock salt on an airplane runway. You're going to get some pretty bad corrosion to airplanes and infrastructure. So you use these non-corrosive products. There are people that have started using them in the road environment, some that have used them for a long time. It's important to note that when you are switching from one product to another, you might be just trading impacts. So you need to know what are the potential impacts to metals, different metal types. For some of these, they are fine with stainless steel, but they will significantly impact and corrode galvanized steel. So it's really important to know the different impacts of each of these things, as well as potentially doing a cost analysis. A lot of these also cost significantly more than the other products, like salt brine or mag chloride. So you, as an individual, as an organization, need to weigh those concerns. And then there are also things that we call bio-based or ag-based additives. And these are typically byproducts of the agricultural industry. So this could be beet juice that's left over. This could be molasses. This could be a waste stream product from making vodka or cheese brine from making mozzarella cheese. The number of these waste stream products it's huge. I've seen all sorts of stuff. Typically what these products are used for, though, they're not a full substitution. They're used as an additive. So you might have a salt brine and then you might add, let's say, 8% beet juice to it. There are huge benefits you can get from adding these, including better performance, working at colder temperatures, and corrosion protection. But there are also impacts that you need to be aware of. If you are thinking about using ag-based products, potential impacts might be, you might want to do an elemental analysis and see what the phosphorus is. And then depending what the parent product is, you might want to do cyanide as well. But if you have specific questions, there are a ton of resources on this. In fact, here is one right here. We just wrapped a project this summer, and we put together fact sheets on the major categories of non-chloride products. So what you have here is the fact sheet for agricultural products. It provides a general description of the category of products, general pros and cons, application rates that are typically used, the temperatures that you would want to use these in, because you don't want to put de-icing products down if it's too cold for them to work. And then the backside is all about impacts. So environmental impacts, corrosion impacts, things like that. And then any special storage and handling. So you can go to this link and you can download these. Everything on this Clear Roads website is free for you to use. State DOTs have paid for this already. I highly encourage you to check out any and all of the resources they have. Working forward into the, well, what if we just totally remove salt from the equation? there has been in the last 10 years really interesting research advancements in heated technology. This is one example of a test pavement at an airport. Essentially, it's a carbon fiber blended in the concrete mix as they lay it down, and it heats the pavement. It works really well. It does significantly increase the cost though. But if you are in a situation where you are trying hard to meet ADA compliance, you have a trouble spot, things like that, this might be the right technology for you. That added cost might be worth the additional effort and material you were trying to use to treat it in the first place. And the link there is to the report with this specific technology, but on the previous page, that report actually had a whole section on heated pavement technologies in it. And so you can look up that if you're interested. And then the last kind of technology I'll talk about are anti-bonding surface treatments. So this is actually based on the technology that they use on airplane wings to prevent ice from sticking to wings. And so the concept has been used a little bit so far in the road environment, but it's more experimental. But recently there have been quite a few papers testing these surface treatments. So you either mix it in the mix design of the concrete or asphalt, or you do a surface treatment. And it actually just prevents that bond between the snow and ice and the pavement from forming or from being strong. So it's really going to help with snow removal operations. It's not going to melt. It's just going to prevent it from really sticking to the road. Again, this is way more experimental, but it's kind of an exciting thing on the horizon. And then the last piece that I always like to talk about, I've had quite a few interviews lately with magazines, and they say, well, what can we do? And I say, the driving public needs to have reasonable expectations. I think one of the biggest concerns is that people expect the photo on the left. They expect either wet roads and clear roads or totally dry roads. That's really almost impossible to attain in most situations. The reality is actually probably what you're going to see on the right, which is where you see that anti-icing truck. That's taken from Bozeman, Montana. That's in town. They're doing the best they can to keep the roads passable. On the upper right, you have two bare wheel paths. That's a highway between Montana and Idaho. On the upper photo, you have a frozen pavement with blowing conditions. So none of these are ideal, but if you are aware of the conditions and you can drive appropriately, that's going to significantly reduce the amount of product that needs to be put out there. Anytime that there is an accident or an incident, usually what happens is the police are going to call and say, hey, we need extra treatment here. There's clearly a trouble spot, and they're going to blast it. And so when we're talking about application rates of 100 gallons or 300 pounds per lane mile, those get blown out of the water. They will throw 1,000 pounds down because they want to create a safe condition. So I'm asking everyone here on the call to think about your actions as you drive. Do you have safe tires? Are you prepared if you get stuck in the snow? Can you just drive slower? Things like that. And I think that's a really important part of the equation that we always need to consider. Nope, for some reason. Nope, there we go. Okay, so this is my last slide, and I'll end this on big or small. There are so many options for small changes that can lead to big outcomes. So this is a picture from our cherry tree. Start with the low-lying fruits. Start with what's easiest for you. Is it calibration? Is it spraying down your pile and pre-wetting? Is it just tracking your numbers? What's going to be easiest for you? Try something out, evaluate it. How did it work for you? Did it not work? Okay, try something else. But don't give up. There are always things that can be tweaked. And if it works for you, tell someone about it. Let me know that you tried something and it worked, and I will start folding your example into my presentations. The one great thing that has come out of almost every change in practice that has led to cost savings or salt savings is that these organizations and agencies can then say, okay, well, we had a great return on investment with that change in practice. How can we now use that money? Do we want to invest in new technology? Do we want to have new training for our hires? Do we want to add more staff? So it's only going to make your organization and your operations better if you reinvest those funds to further support these practices. So with that, I put the ClearRoad site. It's not the only site, but it's a great resource. And please let me know if you have any questions. So I'll pop out of presentation mode now and take any questions.
All right. Thank you, Laura. And we do have some questions that have come up here. So the first one is if you'd be willing to share your slides.
Yes, I will PDF them and send them to you.
Yeah, if you can send them to me, I'll put them up on the website and I hope people ask. So that's great. The next one, Anne has asked, are street sweepers effective in removing excessive salt that has been applied, or are there other ways that excess salt could be removed?
Excess salt. So street sweepers have been shown to reduce the amount of salt that you need to use overall in operations. So if you have street sweepers, for example, a lot of agencies have them for their sidewalks. If you can convert those to use them in the road, that will significantly reduce the amount of solid materials that you need to use because they do a really good job of just getting the material out of the way. In terms of removing salt, I have not heard of them in that context. If you have so much salt on your road that you can flick it off with a street sweeper, you are using way too much salt. Salt is inherently going to run off the road with any moisture event. So if you just have like a light white tinge after an event, I would actually leave that because that means that you don't need to go out and treat for your next event. You already have your pre-treatment on the road. You have your black ice covered already. All that you need to do is let it be there and then not add more to it until you know you need to add more. So being really strategic about leaving salt where it is, if it can help you in the long run, is great. But street sweepers are a wonderful technology. I actually had them in the slide and then I took them out because I ran out of time. So yes, use street sweepers.
Street sweepers to get the road clear beforehand. If there's that much extra salt that you could sweep it, that's a sign you put too much down.
Correct.
I mean, we do recommend if you're homeowner or like work at a business and a lot of extra salt has gone down, like some of the pictures that Laura shared at the beginning, like you can sweep that salt up and reuse it.
Yes.
It's best to do it when it's kind of dry because otherwise it's going to clump up and it's really hard to use, but would recommend that. Otherwise it's just headed, downstream. All right. We had a question that came in through email. Is there a convenient way for homeowners to pre-wet sidewalks? Was the first part of that question.
That's a great question. So you can, at your house, you can make your own like special concoction if you want. You can take the leftover pickle juice. You can go to the hardware store. You can buy whatever liquid product and you can put it in one of those weed sprayers, like those backpack weed sprayers that you pump the top, and you literally walk out and you do a light mist all over your walkways and your driveway. And then that way, when you come out in the morning, if you're worried about black ice, that it should be clear. If you're worried about shoveling is going to be hard, or as your car drives over that snow, it's packing it down, that's going to help with that. And that just be mindful that whatever temperature regime you're in, that's how you're going to want to select your products. And there's really good guidance on that. But typically, if it's going to be like 10 degrees or warmer, you can use a sodium chloride or a salt brine. Anything colder than that, you might want to look into, like at the hardware store, they sell they call it pet safe. And those are usually acetate or formate based deicers. They're going to work at slightly colder temperatures. Or if you have like mag chloride on hand, most people don't, but you can go to like a farm store and you can get a bag of calcium or mag flakes that they use in feed for animals. And you could make your own brine with that. So yeah, it's totally reasonable. Try pickle juice, see how it works. I want to see a picture of it.
Would caution people, there's no truth in labeling. So sometimes things will say pet safe, and it might just be that the salt grain is rounded and not sharp. So I've seen that kind of stuff as well. So just be careful. When Laura's saying pet safe, it's something that's a non-chloride
Right.
product. So the next question that came in via email was, are you familiar with the approaches to ice commonly used in Iceland? I recently heard from a person who moved here from Iceland, and they spoke about a very different approach to dealing with icy climate with very little salt.
We work with folks in Europe all the time. I can say I've not worked with folks in Iceland, and I would love the opportunity to go and learn from them. We do work with folks from Norway and Sweden and Japan a lot, and they actually have really helped push new ideas onto the US field of research and applications. A lot of the equipment, like huge brooms that cover 2 lanes of road, they're being used in Norway. And so when they came and they showed us, all the DOT guys were like, oh my God, that would be wonderful if we didn't have to use any de-icer and we could just broom the whole road. So yes, we do work with international folks and we do try to incorporate it. But if you know specifically about what folks are doing in Iceland, please share it with the group. Do a little write-up for Allison so she can share it with all of us, or reach out to me. I'd love to hear about it.
Yeah, and I am going to grab here. Wilf Nixon and Mark DeVries were on in December talking about what we call on the cutting edge, like newer practices. And they shared a few things from Northern Europe and also Japan. So I'm going to put that, say some international case studies. Then we had a question, what happens if we reduce chlorides from road salt and water is still showing high levels since the chlorides don't break down? Do you foresee a time when salt will be banned?
I think it's possible. I think what we're trying to encourage folks to do now is to cut back as far as you possibly can, to not have any excess applications, doing the best we can so that we don't get to that point. I think, unfortunately, the trend that we're seeing in surface and groundwater in the Midwest and out east is this very slow rising chloride levels. And it is worrisome because we may get to the point in time where we do have to do just like a dramatic shift in winter operations, totally away from chlorides. I can tell you that all the other de-icers, they're going to have some impact. So you're not going from chlorides impacting to no impact. There will be an impact. It's just a matter of what it's going to be, and the cost is also significantly higher. In my, ideal world, you would have all these technology options available where if you don't need to de-ice, you don't have to. You could use your sweeper. You could incorporate some heated pavement technology in critical areas. And it's a more kind of nuanced approach instead of just a blanket approach of a single product. But what I encourage all students nowadays is that no new de-icers have been invented. These have all pretty much been on the market for a long time now. We need some big fracturing change to occur to totally get away from chlorides. At this point in time, there's nothing that could fully replace it, with our expectations of having safe and passable roads. So I'll leave it at that. So hopefully it's not too doom and gloom.
Yeah. And also the cost, right? I mean, the cost of a lot of the alternatives is like 20 times as much, right?
Right.
All right. So we got a question about, are there significant negative ecological impacts from cheese brines and other forms of brine?
Yes. So any brine is going to impact, whether it's a salt brine and the chlorides build up in the environment. With the cheese brine project specifically, we wrapped a project with Colorado recently, and the report can be found on their website. We did quite a bit of testing. We wanted to know what was in it. We worked with the state to get beneficial use permits to apply it. So what was flagged in that project was phosphorus. Most agricultural products, and by agricultural, I guess, waste stream products, they might have high phosphorus. So we knew that that was a problem. So the company that produced the cheese brine, actually in-house in their lab, they came up with a flocculation method. So they actually added ferric chloride to the mix, and it helped pull phosphorus out. And so we did a ton of testing on that product that they ended up afterwards. It did a great job removing the phosphorus, but what we found was as it pulled the phosphorus out, it reduced the benefit of that, byproduct. So the corrosion protection was reduced as you remove that material from it. So there's going to be a balance when you're using these. The reason I mentioned cyanide previously is if you're using like an apple product, apple seeds, and a lot of seeds and plants naturally use cyanide to protect them. And this can accumulate over time. The other reason cyanide is important is a lot of salts use an anti-caking agent in them naturally, not naturally, it's added, but it's added early on in processing. It's added at a very small amount. But this can concentrate over time in industrial processes. So spend $1,000, do an elemental analysis. If you are getting a waste brine, it's worth it because you want to know what you're dealing with. You don't want to be in a position where you're getting like a waste brine from fracking or something and you haven't done any testing and then you find out it has radioactive components to it. That has happened and it puts you in a really tough spot. So definitely always opt for a little bit of testing ahead of time.
Thanks, Laura. Next question here. What is worse for the environment, applying too much salt to roads or applying too much sand to roads?
That's a good question. And it's like, I don't know if they can balance the scale evenly. Sand comes from the environment. I guess so does salt. Sand does have its own impacts. And in some parts of the US, parts of the world, there are no salting zones and there's no sanding zones. And that also, the no sanding may occur at specific times. So in larger valleys, Greater Salt Lake area is an example, Denver, where I live. If there is an inversion, so that air mass is just sitting low in the valley, they're going to have a no sanding zone because as you sand the roads, it gets kicked up by cars and broken down and you get fines in the air and then it can really reduce air quality. So that's one concern with sand. The other one is as the sand leaves the road environment, where is it going? Is it going to a place near the road where you can actually sweep it up and reuse it after you clean it? Or is it ending up in a creek, a river, a stream, a lake? There has been some studies that have shown that as the sand specifically goes off the road, if it ends up in a river environment, it can start clogging riffles, which is not ideal for aquatic species. So, potential impacts to water quality, potential impacts to air quality, but if you invest in a cleanup program, you can really minimize those.
A lot of variables to consider, especially like, kind of geographically, where are you?
Right.
Because I know this question was actually asked on Monday of Hillary Dugan, who's a professor at UW-Madison. And, she was talking about in the Madison area throughout Wisconsin, it's fairly sandy, right? And we do have sand that is mined in Wisconsin. We do not have salt that is mined in Wisconsin, right? So in terms of what's changing the natural kind of what would be natural kind of in the water systems that you're looking at. And I know also in cities, if the sand's all going into the sewer, like that's a big problem too, right?
Right.
Okay. A question: how soon before a snow event can you pre-treat or anti-ice?
So some people do it, 6 hours, 12 hours, 24, the earlier you do it before the storm event, the more potential that it will dry out and that dried salt will just kind of get kicked off by cars. But the important thing to think about, you don't want to do it like a week in advance, ideally. But if you have residual salt on the road, that's great. That's going to benefit you. You want to think about what's going to work best for your agency or your organization or your private business. Do you have time 4 hours before the snow event? For example, if you know snow is going to start at 2 a.m, don't stay up till midnight and try to hit it then. Hit it at the end of the workday once the cars have cleared out of the parking lot. That would be the perfect time to do it. And then you can come treat it early in the morning and get that snow out of the way. So there's a balance of timing, convenience, and I wouldn't push too far outside of like a day ahead of time.
And I have in Wisconsin, I know some municipalities more like maybe small to mid-size that don't have the like staff capacity to do it a day ahead. So they start to even I've heard 3 days ahead of time and still good results. I mean, I think a big part of it though is like, do you really know what's coming at you 3 days ahead of time? And if it ends up being rain and not snow, well, that's all washed off, right?
Right.
But yeah, just wanted to share that. So I think that's what we have right now for questions. You can wait a second more. Oh, actually, sorry. There was a question about where does the majority of road salt come from in the United States?
So that's a great question. So we have naturally sourced a ton in the US. There are mines in the Great Salt Lake area. I think there's a couple mines in Michigan and Kansas. So these are natural salt deposits from, geologic timescale. They're big, they're huge, and they source salt from there. On the coasts, so I know like on the coast, West Coast near San Francisco, because I grew up in that area, there are salt ponds. So they create solar salt there where they essentially mine salt directly from the ocean. They let the water evaporate out. And they can do that pretty much in any coastal area. There are some people that pay for salt from like the Middle East, from the Mediterranean. Yeah, and honestly, it usually comes down to the cost of the salt. So if you're going to have to ship the salt, it's probably going to be more expensive. Whereas if you can source it locally, it's going to be a better price for you. If you are interested in salt sources and salt cost for DOTs, on that Clear Roads website that I showed, they actually have a map and it's updated every year where DOTs say, this is what I pay for salt. This is where I get it from. This is how much I use. And they did that on purpose because they wanted to know what everyone else was paying. So now it's a really fair field where the only difference in cost and salt is basically transportation cost.
Which is significant, right? I mean,
it can be.
in the Madison area, I mean, I work with people across the state. So I know kind of like in central Wisconsin, counties are paying $20 more per ton than they are if they're right, on Milwaukee, right? At the port, Green Bay.
Right.
So it's heavy.
Yeah. And one interesting point is, some states naturally have salty soils or salt deposits. But for Colorado, one of the big pushes for this using the cheese brine there is the cheese brine company, they have to bring the salt in to treat the cheese. So that means all the salt used in Colorado is brought in from out of state. So if we can reduce the overall amount of salt coming into the state, that's going to benefit everyone. It's going to be cost savings for everyone. So that's why these kind of partnerships with existing brines could be great. It could lead to a lot of savings.
All right. Well, thank you so much, Laura. I think we're going to call it 15 minutes over here. Thanks for your extra time. No, you're good. It was great with all the questions. And yeah, I just want to say thanks again to everybody for joining in this week. In addition to, Salt Awareness Week webinars, we have webinars throughout the year with researchers like Laura, practitioners, and citizen science monitors, people who are out there taking a look at the creeks in their backyard. So please do check those out and continue to share the word about what you've learned this week. Reach out to me if you have any questions. I'm sure Laura would be happy to take questions too. And she shared so many resources from Clear Roads. There's a lot out there, so it's just hard to know kind of where to get started. So thanks again, Laura, so much. Wishing you all the best this winter, and hopefully we'll catch up at one of the conferences soon.
All right. Thanks. Bye, everyone.